Hello all. So far we have seen physiological roles of gibberellin and gibberellin signaling. Now we are going to see about the basic biosynthesis of gibberellin, inhibitors of gibberellin, location and synthesis of gibberellin, and translocation of gibberellin. First we are going to see about translocation of gibberellin. How gibberellic acid is being translocated. Translocation of gibberellin. Translocation is bidirectional. First thing. Second thing is when synthesized in root, they are transported through xylem. When synthesized in shoot, they are transported through phloem. There is no polarity. Meaning in auxin we have two types of transport, that is polar transport and non-polar transport, and basipetal transport. In gibberellic acid there is no such condition and no such polarity is found so far based on the transporting mechanisms of gibberellin. So no polarity mechanisms are involved. They are bidirectional. If synthesized in root, they are transported through xylem. If synthesized in shoot, they are transported through phloem. These are the translocation details of gibberellic acid. First part thing is done, that is translocation of gibberellin. First thing is bidirectional. What will happen in case of synthesized in root, in case of synthesized in fruit, and there is no such polarity that is seen in case of auxin. These are the basic details about translocation of gibberellin. Next we will see what are the inhibitors of gibberellin. Inhibitors means what are the components that inhibit gibberellin. What are the compounds that inhibit gibberellin? First up is phosphone D. Phosphone D. First compound. Second compound is AMO 1618. Third compound is cyclosyl. Phosphone D, AMO 168, cyclosyl, CCC. Next thing is ansimidol. Last thing is last thing is plasobutracel. So phosphone D, AMO 1618, cyclosyl, N-mysitol, plasobutracel are the various inhibitors of gibberellin acid. Means if these components are given or if these commercial chemical components are included or induced into the plant, the functions and the mechanism of gibberellin and physiological roles of gibberellin will be inhibited. It includes phosphone D, AM1618, cyclosyl, CCC, antimycetol and plasobutracel. These are the 5 components. These are asked in IICSIRNet Life Sciences examination. That is previous year questions. So make a note of it, of these components. Antimycetol is very important. Antimydol. I'm sorry, it is. I will spell it again. ANCYMIDOL. And cymidol is the correct spelling. ANCYMIDOL. CY and cymidol. And cymidol. Phosphon D, AMO1618, cyclosyl, and cymidol and plasmabutrysil. Okay. Next we are going to see about biosynthesis. Biosynthesis. Next we are going to see about biosynthesis. Biosynthesis will take place in biosynthesis of this gibberellic acid occur in three different organelles, that is plastid, then cytosol, endoplasmic reticulum. Plastid, cytosol and endoplasmic reticulum. Plastid, cytosol and endoplasmic reticulum are the three different organelles. These organelles should be by-hearted in order, because the final product of this plastid will enter cytosol and this final product of cytosol will enter ER. Then we will be getting gibberellic acid from endoplasmic reticulum. So this order of PCE, mnemonic PCE, plastid, cytosol and endoplasmic reticulum in order. We will see what are the things occur in each thing. Isopentyl, that is IPP, is a 5-carbon compound. Next it is converted into dimethyl allyl pyrophosphate, 5-carbon compound. Then it is converted into geranyl pyrophosphate. It is 10-carbon compound. It is converted into farnesyl pyrophosphate, 15-carbon compound. It is converted into geranyl pyrophosphate, that is 20-carbon compound. It is converted into ENT kynurenine. This is the final product of plastid. All these occur in plastid. I can't type it all these things, this flow chart, so I am drawing it. Please adjust with my drawing. IPP is being converted into dimethyl allyl pyrophosphate. Dimethyl allyl pyrophosphate is being converted into geranyl pyrophosphate. Isopentyl pyrophosphate is being converted into dimethyl allyl pyrophosphate. Dimethyl allyl pyrophosphate is converted into geranyl pyrophosphate, farnesyl, then geranyl pyrophosphate, then ENT kynurenine. ENT kynurenine is the final product of plastid. So after plastid, as with mnemonics, plastid will convert, it enter into cytosol, then it will enter into ER. Then we will see what occur in case of cytosol. This geranyl pyrophosphate is being converted into ENT kynurenine, 20-carbon compound, cytosol. So geranyl pyrophosphate is the final product of plastid. It enter into cytosol. ENT kynurenine will enter into ER as GA12. GA12 will act as a precursor for all gibberellic acid. Long story short, I will correct about this ENT kynurenine now. IPP is a 5-carbon compound. It is converted into dimethyl allyl pyrophosphate, again a 5-carbon compound. It is converted into geranyl pyrophosphate, 10-carbon compound, converted into farnesyl pyrophosphate. It is a 15-carbon, please correct, it is a 15-carbon. Farnesyl pyrophosphate is always a 15-carbon compound. Please make a note of it. Farnesyl pyrophosphate, we will be studying this in secondary metabolite of terpene as well. Farnesyl pyrophosphate is a 15-carbon compound. Geranyl pyrophosphate is a 10-carbon compound. Please make a note of it. It is very important to know the number of carbon atoms involved. Farnesyl pyrophosphate is converted into geranyl pyrophosphate, which is again a 20-carbon compound. Geranyl pyrophosphate is a 20-carbon compound. So 5-carbon is converted into dimethyl allyl pyrophosphate, then into 10-carbon compound, that is geranyl pyrophosphate, 15-carbon compound, that is farnesyl pyrophosphate, then 20-carbon compound, that is geranyl pyrophosphate. This occur in plastid. This occur in plastids. Then the geranyl pyrophosphate will enter into cytosol. This geranyl pyrophosphate is converted into ENT kynurin. Cyclase is an enzyme that is involved in this conversion. Then it will enter into endoplasmic reticulum. Monooxygenase is involved. Give rise to gibberellic acid 12, and it acts as a precursor. For all kinds of gibberellic acid. Overall, this is so. Please correct. If in previous slide I have mentioned that geranyl pyrophosphate is converted into ENT kynurin in plastid. Please correct it. Geranyl pyrophosphate is synthesized in plastid, and it is converted into ENT kynurin in cytosol, and it is converted into Ga12 in endoplasmic reticulum. Keyword is PCE. Plastid, cytosol, endoplasmic reticulum. ENT kynurin is in cytosol. Ga12 endoplasmic reticulum. IPP, the dimethyl allyl pyrophosphate. Geranyl pyrophosphate 10-carbon compound. Farnesyl pyrophosphate 15-carbon compound. Geranyl pyrophosphate 20-carbon compound. Very important in CSIR exam point of view, and also we will be learning this again in secondary metabolites, terpenes as well. Okay, hope this thing is clear. Cyclase is an enzyme that is involved in conversion of geranyl pyrophosphate to ENT kynurin. Then in cytosol, GA12 precursor, as I said, will give bioactive component of GA4, and GA53 will give rise to GA1. Okay, this is pointer. GA12 will give rise to 4, 53, 1. This will be asked in exam. And remember the numbers. 12 gives 4, 53 gives 1. This is odd number, this is even number, gives even number. So somehow try to remember this. Hope in this video so far what we have seen, let us sum up again. End of this video, we have come to the end of the video. So far we have seen about biosynthesis, gist of biosynthesis. It occurs in plastids, cytosol and endoplasmic reticulum. Plastids, end product is gernyl pyrophosphate 20 carbon compound. In cytosol, the end product is ENT kynurin. In endoplasmic reticulum, ENT kynurin is converted into GA12. This is the overall gist of biosynthesis. Okay. Next we have seen about transport. Transport we have seen about, it is bidirectional. Major thing is bidirectional. No polarity is involved. These are the two major key points to remember. Next thing is we have seen about inhibitors. What are the inhibitors we have seen? Let's try and recollect. First thing is phosphine D. Second thing is AMO1618, cyclosyl, N-mysitol are the major inhibitors. Next thing new thing we are going to see about is site of synthesis. Site of synthesis. Apical tissue. We have seen what is apex. We will be seeing about apical dominance when we talk about auxin. It is manufactured in apical tissue, young leaf, immature, developing fruit. Another pointer we have seen is memory based pointer, that is GA53 will give rise to GA1, GA12 will give rise to GA4. This is pointer. So please make a point of it. Hope so this video is clear. We have seen 4 different headings of today's thing, that is location, site of synthesis, inhibitors, biosynthesis and a pointer. Hope this video is very clear. Hope this video is very helpful. Thank you for watching this video. Thank you.